In this video, we are going to finish what we started with our ultimate 2D platformer controller. In part 1, we made basic movement with a dedicated run button, and we made a versatile jump that includes all of the advanced features that you would want your platformer jump to have. Now we're going to take it to the next level and introduce a wall slide, wall jump, and a dash. You will have full deceleration control with the wall slide because maybe you want it to go right into the wall slide speed as soon as he enters that state. Or maybe you want momentum to carry him down a bit first. It really depends on the feel that you're going for. You have direct control over the wall jump angle, as well as how the character controls during the wall jump. If you want a more Hollow Knight style wall jump, you can crank these down and you'll have no movement control for a fraction of a second. Or you can move these up and then you'll be able to fight against or work with the momentum of the wall jump. We're also going to implement a wall jump buffer because your player might turn away from the wall before hitting the jump button, and they'll expect a wall jump to happen because when it doesn't, it's really jarring. I love the dash from Celeste, so we're taking inspiration from that and implementing an 8 directional dash. And just like Celeste, he can do lots of dashes on the ground with only a limited amount in the air. You have full control over how many air dashes your player can do though. So I want to be clear, this is not a beginner level character controller. It's almost 1,000 lines of code when all is said and done. So if you want to try it out before committing to following this video, you can try out the game at itch.io. I've linked it down below. Again, I do recommend you download it so that you can properly experience just how smooth it is, but there is a browser version included for your convenience. For my patrons, I've made this project available in GitHub, and as a bonus, they will also get this controller implemented in a state machine, which is a nicer and more modular way of making a character. So if you want to check that out, you can head on over to Patreon. And thanks so much to all of you over there who already support us. And with that, let's get into it. I'm very proud of this controller. It controls really nicely. I hope you guys enjoy, and I hope you use it to make some really awesome 2D games. Ready? Let's go. So to hopefully make this a little easier so we're not jumping around between different scripts, I'm going to show you all the changes to our player movement stats script first, and then we'll start changing the movement script. So in our player movement stats, first we need to add these two variables, which will control how much we're going to be able to move during the wall jump phase. We'll also need to be able to detect wall collisions, so we'll create a wall detection ray length, as well as a ray height multiplier. Dragging this up and down will adjust our wall detection zone like this. Obviously, you don't want to make it too tall or your player's going to think that they're touching a wall when really they're just touching the ground. We're going to add this bool here. You may or may not want your player's air jumps to reset on a wall slide, so we'll just bake that option right in. Next, we want our wall slide stats. And now our wall jump stats. And now our dash stats. And our new debug option as well, which will let us visualize the wall detection zone. And we're nearly there. We also want to create an array of dash directions, which we will later use to compare against our input to see which direction we're actually going to dash in. And we want to normalize the diagonal directions, otherwise you're going to end up dashing faster diagonally than you do in the 4 main directions, which is weird. And finally, since we have a whole separate set of options for our wall jump, we need to calculate our wall jump gravity, initial wall jump velocity, and adjusted wall jump height, just like with our normal jump. Okay, there we go. Now let's open up our player movement script. So again, we're just going to get the new variables out of the way so that we can focus on the fun stuff. First, we need 2 new raycast hit 2Ds for the wall hit, and a bool, and a couple wall slide variables, quite a few wall jump variables, and quite a few dash variables as well. And now that we're making some changes and additions to the controller, there is some refactoring we should do that makes sense to clean the script up before we add anything else. So first, this check for if we're landing, it doesn't, to me, make a lot of sense to keep that in the jump function anymore. So I'm going to move that into its own function called land check. And we'll call that in update after the jump. And also inside of our jump function, there's this section here which handles normal falling with no jumping. Let's move that into its own script called fall as well. And we'll call that in fixed update after the jump. We're also applying velocity to our rigid body in a couple of places, which I don't like. We're doing it here in movement. Let's get rid of that. And we're doing it here at the end of the jump as well, right after clamping the vertical velocity. Let's get rid of all that and instead create a new method called apply velocity, and we'll clamp it here. And then we'll just change the velocity by plugging in the horizontal velocity and the vertical velocity here in one place, which I just think makes way more sense. And then we'll call this at the end of fixed update after all the other calculations and checks have run. I also think it would make a lot more sense to rename move velocity to horizontal velocity and change it to a float as well. So let's see what needs to change after that. So this here, just get rid of the X. And here in the move, target velocity can now be changed to a float. As well as change this from vector2.lerp to mathf.lerp. And this is just going to 0 instead of vector2.0. There we go, much better. Now, if you set up your input like I did, then you might want to change your move function just slightly. We're going to add a move threshold to our movement stats. And in our move function, instead of checking against vector2.0, we'll say if the absolute value of the X on our input is less than our movement threshold. If we don't do it this way, then our character will move even if we're just pressing up or down, which was really bugging me. And then instead of checking for a vector2.0 here, let's check if the absolute value of the X on our input is less than the threshold. And one final change, really simple, in our jump function, going down to this gravity in ascending, but not past apex threshold. This should be if we're not fast falling. You're not going to feel any kind of a difference in the jump function with this, but there were a few frames where this was running and this down here was overriding it afterwards, which just made debugging a little bit confusing. So this is just cleaner. Okay, so it's all nice and clean and makes more sense for our expanded moveset. Let's start with the wall slide. And to do that, we need to know when we're touching a wall. So down here, we're going to create an isTouchingWall method, and we'll call that in collision checks, which gets called in fixed update. There's nothing too different happening here compared to the other collision detection functions, except that we need to take our facing direction into account. But we're just doing a box cast slightly in front of the player. If it collides with a wall, then yes, we're touching a wall. If it's not, then we're not touching a wall. And again, if you want to be able to visualize the collision detection, here you go. I do recommend adding this in so that you can get your ray height multiplier variable set just right. The last thing you want is a player thinking they are going to do a wall slide when they hit the edge of a little platform, but they don't because the wall detection is really tiny or something like that. So let's create a wall slide check and a wall slide. The check we'll call in update, and the actual wall slide we'll call in fixed update. For the check, we'll say if we are touching the wall, we're not grounded, and we're not dashing, and if our vertical velocity is less than 0, so we're moving down, and we're not already wall sliding, well, then we are wall sliding. So if we're not wall slide falling, stop that and set is wall sliding to true. And here, if we want to reset our number of used jumps on a wall slide, we'll do that here. Now, we want to figure out when we're falling off of a wall. So we'll say else if we are wall sliding, but we're no longer touching a wall and we're not grounded and we're not already wall slide falling, well then we are now wall slide falling. And at this point, I just want to stop wall sliding. So we'll create a function for that checks if we are wall sliding, increase our number of used jumps, and we're no longer wall sliding. If you fall off of a wall and your player has one normal jump and one air jump, I feel like they should only have one air jump left, which is why we consume a jump here, but that's your call, that's optional. And we'll call that function here. And also, if neither of these statements are true, then just plain stop wall sliding without the wall slide falling. Okay, now the fixed update part is easy. We'll just say if we're wall sliding, then we'll lerp our vertical velocity to go from what it is down to our wall slide speed based on our wall slide deceleration speed multiplied by time.fixedDeltaTime. Now, here's the thing. We have so many floats and bools up here for each of these moves, and we need an easier way to reset all of them. So in my jump section, I'm going to create a new method called resetJumpValues, because we'll be calling this as soon as we wall slide or once we start dashing. Obviously, once we're doing those things, we're no longer jumping. I'm also going to prematurely create a wall jump section just so that I can go ahead and create the reset wall jump values method here. And same with the dashes, we want to be able to easily reset that as well, along with our number of used dashes. So now that that is out of the way, we're back in our wall slide check. And if we've started wall sliding, we'll reset our jump values and our wall jump values and our dash values. And also we'll reset our dashes if we have that option checked in our movement stats. Now, before we are able to test this, you'll notice I'm checking here to make sure that we're not dashing, even though we haven't set up the dash yet. It's just easier to do things sequentially. So we're going to go back to some of our older methods and update all of those checks as well with all of our new stuff. Otherwise, testing this along the way is going to be nearly impossible. So let's just do all of that now to ensure that our new movements work correctly. So back in fixed update, we have all our movement code here. We need to change this because if we're not grounded, we might want to apply our wall jump acceleration and deceleration. So if we do want to use those, then we'll use them. Otherwise, we will just use regular airborne acceleration and deceleration. In our apply velocity method, we only want to do this clamp if we're not dashing. And if we are dashing, we want to plug in something much higher to make sure that we can reach those speeds that we're looking for with the dash. In our fall check, we need to make sure that we're not wall sliding, and wall jumping, and dashing, and dash fast falling in order for this to be called when it's meant to. And our land check is about to get a bit longer as well. We also want to add, or is wall jump falling, or is wall jumping, or is wall slide falling, or is wall sliding, or is dash fast falling. A land could happen after any one of those. And if we do land, let's just get rid of all of these and we'll enter our reset jump values method instead, as well as our stop wall sliding, our reset wall jump values, and reset dashes. Now, as it stands, if you're dashing on the ground, once it ends, the land method will fire, which means if you have a land animation and particles and all of that stuff, they're all going to fire after every single ground dash, which is not ideal. So we'll say right here, if we are dash fast falling and we're grounded, well then it must be from a dash, so we'll reset our dash values and return. This way, no effects or animations, which you should enter after this check, will fire. And either way, we still need to reset our dash values, so we'll enter that here as well. In our move function, we only want this to run if we are not dashing. We don't want any additional forces happening while we're dashing. Next, for our jump, if the jump button was pressed, we don't want this to potentially conflict with our wall jump. So if we are wall slide falling and our wall jump post buffer timer is greater than or equal to 0, we're going to return. That's because if this is true, a wall jump will be called due to our wall jump buffer, not a normal jump. So we don't want to allow the rest of this function to continue. Also, if we are wall sliding or we are touching a wall but are not grounded, we're also going to return because again, that would just be a wall jump. Okay, we're nearly done. In our double jump section here, we do need to add if we're jumping or wall slide falling or air dashing or dash fast falling, and we aren't touching a wall. And if we were dash fast falling, then turn it to false since we want our jump gravity to take over and to not be handled by the dash function. And down here, add in if we aren't wall slide falling, okay? And finally, in our initiate jump, we want to reset the wall jump values. Okay, so I know that was a lot, but it's only new stuff going forward, no more refactoring and changing old stuff. And now we should be able to properly test out our wall slide. It should work whether we jump into a wall or whether we just fall off the floor and go right into a wall slide. Perfect. But a wall slide never feels complete without a wall jump, so let's add that in next. As with everything else, we're going to make two functions, a wall jump check and a wall jump. The wall jump check will call in update, and the wall jump will call in fixed update. Now, just like with our jump, we need to update our wall jump buffer timer. So we're going to create a function called shouldApply post wall jump buffer, and that will only return true if we are not grounded and we're either touching the wall or wall sliding. Otherwise, we're going to return false. So down here in our timers, if shouldApply post wall jump buffer is false, then we're going to decrement our timer. Okay, now for the wall jump check. If we should apply our wall jump buffer, then let's update our timer so that it's above 0. We also need our check to see if we need any wall jump fast falling. So if our jump button was released and we're not wall sliding, not touching a wall, and we are wall jumping, then we also need to check if our vertical velocity is greater than 0, meaning we're moving upwards. If so, and we are past the wall jump apex threshold, then we'll change a few flags and update our wall jump fast fall time and change our vertical velocity to 0. If we are not past the apex threshold, then we are wall jump fast falling, and we need to update our fast fall release speed to whatever our current vertical velocity is. And finally, if the jump button was pressed and our wall jump buffer timer is greater than 0, then we need to initiate a wall jump. So let's set up a method for that. So we are wall jumping, and we want to use our wall jump move stats, stop wall sliding, reset our jump values, reset our wall jump time, change our vertical velocity to actually start the jump, and then we also need to calculate our horizontal velocity. So we're going to create a direction multiplier, and we need to find a hit point based on our last wall hit collider. We're using the last wall hit because you may not currently be touching a wall anymore since we allow a wall jump buffer. So we use the last wall hit. And if the wall is in front of you, then we're going to send you flying backwards. Otherwise, we're going to send you flying forwards. And finally, we'll apply our new horizontal velocity. So this is all great, but because of all those checks we added into our jump function earlier, our jump gravity won't be applied. So we need wall jump gravity to be applied. This is going to work extremely similarly to how we handled it in the jump function as well. If we're wall jumping, well, we need to increment our wall jump timer because once that timer is over, we no longer want to use our wall jump move stats. At that point, we'll switch to our regular air stats instead. We also want to apply fast falling if we bump our head at any point during the jump. Now we're going to handle gravity in the ascending part of the jump. So we find our apex point. And if it's past our threshold, then we increment our timer and change our velocity based on whether or not our hang time has passed. And if we're ascending, but we're not yet past the apex threshold, then we're just going to apply normal wall jump gravity. Now, if we're descending, but we're not fast falling, then again, we'll use wall jump gravity and ensure wall jump falling is turned to true. And if we are fast falling, then we'll handle our vertical velocity based on whether or not we've surpassed our time for upwards cancel. And make sure we increment that timer. So again, this is almost exactly how it worked with the jump function. Awesome. So you should be able to test it now. You'll notice that this was designed for the wall jump to work whether you are wall sliding first or not. I really like responsive jumps, so I wanted to make sure that when you press the jump button, a jump will happen no matter where you are or what your character is doing. So as long as you are touching a wall, you will do a wall jump. And also you can see if we're wall sliding and we turn and then jump, we're still doing a wall jump away from that wall, which is awesome. Okay, now for the dash. As always, dash check and dash. Dash check will get called in update. Dash will get called in fixed update. So for the dash check, we first need to update our input manager to account for a dash button press. As well as our input action asset here. Okay, next we'll need to check if we pressed the dash button. And then we need to distinguish between a ground dash and an air dash. So if we're grounded, or our ground timer is less than 0 and we aren't already dashing, then initiate a dash. And let's just make a method for that real quick, and we'll call that here. Otherwise, if we are not grounded and not already dashing, and our number of dashes used is less than our allowed number of dashes, well then we're air dashing and we initiate a dash. And here we actually also need to check if our wall jump post buffer timer was greater than 0. If so, we're going to decrement our used number of jumps. We're doing this because when you leave a wall slide, it consumes a jump, which isn't really fair if you're leaving the wall because of a dash. And let's also make sure that it doesn't go below 0. Okay, so let's handle the initiate dash function before going to the dash function, which is going to handle the gravity and all of those things. So first we want to update our dash direction. And now we want to compare our movement to our 8 directions and see which is the closest to determine which direction we want to dash in. So we need to loop through all the directions to compare. But if we hit the direction dead on, well then we can just use that direction and break out of the loop. If not, then we need to check the distance between our input and the dash direction array. But if this is a diagonal direction, well then we are going to apply a bias that we can set against our diagonal direction. I noticed that without this bias that I often wasn't going diagonally when I thought I should be. So we can use a bias to correct for that. I really highly recommend that you just play around with that setting, play around with the dash and the movement until you get something that just feels good. I set mine to 0.4 and I thought that felt pretty good. Now, if it's not diagonal, but the distance is less than the minimum distance, then that will be our new closest direction. And we also need to handle what to do if there's no input whatsoever. I personally think that a character should always just dash forward in their facing direction. So if we're facing right, vector2.right, if not, vector2.left. And finally, after all of that, our final dash direction will be our closest direction. We'll increment our number of dashes, say that we are dashing, reset our dash timer, as well as our dash on ground timer. And finally, reset our jump values, our wall jump values, and stop wall sliding. All right, now as for the gravity and all of that stuff while we're dashing, we'll say if we're dashing, we'll increment our dash timer. And once that timer is over, if we're grounded, we'll reset our dashes. And we're no longer dashing or air dashing. And we do want to make it possible to jump while dashing on the ground. So we'll say if we're not jumping and not wall jumping, then we'll reset our dash fast fall time and set our fast fall release speed. And so long as we're not grounded, set our dash fast falling to true. And then return to cancel out of this method, since this is what happens after our dash timer is over. But if that's not the case, then we'll set our horizontal velocity based on our dash direction. And if our dash direction.y is something or we're air dashing, then we'll also need to change our vertical velocity based on the dash direction. Now, if we're no longer dashing, but we're instead dash fast falling, meaning the dash is over, well, if we're moving up, then we want to do the handling for our time for upwards cancel. Same as the wall jump, same as the jump. You could copy and paste it and just replace the variables if you want. And make sure that you're incrementing your timer. If we are not moving up, then we'll change our vertical velocity based on our gravity multiplied by our dash gravity on release multiplier. Okay, and finally, we need to handle the dash timer. If we are grounded, then we will decrement our dash on ground timer because we do need some sort of limit to our number of ground dashes. And I do seem to have an error here, though it looks like it's just because I put an F after an integer here, so that should clear that right up. And now you should have a nice dash that goes in 8 directions. You can air dash, you can jump while ground dashing. Again, all of the default values I gave you feel pretty good, but of course you're going to want to play around with them until you get a controller that you like. Thank you so much if you followed this all the way to the end. I know it wasn't easy. That was a lot of code, but I really hope that you enjoy the platformer controller that you now have. This controller would work great for any kind of platformer, and you have all of the controls available in the inspector to make it function like a Celeste controller or even more like a Hollow Knight controller if that's the feel that you're going for. And again, this is available in a state machine on Patreon if you're interested in that. Thanks so much for watching, guys. See you in the next one. Bye.